Hi everyone and welcome. My name is Vlad Vlaschanov. I'm a Principal Database Specialist Solutions Architect here with AWS. I've been with AWS for almost more than 6 years now, and I've worked with many databases over my career, mostly focusing nowadays on MySQL-based databases and that we offer in specifically our managed database services. Before we get started, I wanted to kind of highlight a little bit the learning objectives for today's session. We're going to focus mostly on migration topics. And but before we do that, I'm going to do a brief introduction of Amazon RDS and also focus a little bit on seeing how common administrative tasks change for a DBA or an administrator or system administrator managed to our managed database service. Now, this is a workshop. We will have a couple of demos, and you can actually follow along with those demos. If you download the lab guide from that URL on the screen, you can follow some of those steps and also experience for yourself how some of these migrations can be performed from MySQL databases that you're managing yourself, moving to RDS MySQL. And so let's get started.
Vlad, before we get started, can you refresh us what Amazon RDS is and why it is a great place to migrate MySQL workloads?
Absolutely. So what is Amazon RDS, right? Amazon RDS is a managed relational database service. And we provide a choice of 6 popular database engines. You've got 2 commercial engines, Microsoft SQL Server and Oracle, available, and you have 3 open source engines. MySQL, PostgreSQL, MariaDB. And in addition to those engines, we also provide our own Amazon Aurora database engine is compatible with MySQL and PostgreSQL. The only difference is that Amazon Aurora is an engine that we've built using a cloud-native architecture that takes advantage of the distributed nature of cloud computing. And to provide higher levels of throughput for MySQL or PostgreSQL engines. But all of these engines together, what we do is we provide a management layer around these database engines where we automate certain tasks, such as backups, high availability, failovers, patching, and that makes this platform really, really easy to use because it takes off a lot of the administrative burdens from the developers, from the database administrators, or other generally for the organizations that are managing these databases. So first of all, Amazon RDS is easy to administer. You get to deploy databases with a simple set of API calls or points and clicks through an interface, just telling us what sort of compute capacity, storage, and configurations you need for the database, and then we will actually deploy databases for you with those configurations. We also provide out-of-the-box security and compliance features built into the platform. So you can, for example, encrypt the data at rest or in transit and be able to take advantage of these databases in restricted compliance or regulatory environments. We also provide out-of-the-box availability and durability features. We have a feature called Multi-Z, which provides you with a highly available database implementation where data is replicated and we automate failovers. We also provide you backups and snapshots. And, all of these is also delivered with performance and scalability features in mind. You can choose the type of storage and the storage characteristics that you need for your databases. You can choose configuration options. You can even scale your compute or your storage needs as your database and your workloads need to change. And all of these features together make Amazon RDS a very compelling solution for running MySQL databases. And the value, like I mentioned, like I hinted before, the value of the managed service is letting administrators or developers focus on what's really important for the business. We have a saying here, right? A phrase, we call that undifferentiated heavy lifting. These are all of the tasks that an administrator or developer have to do to manage the database, such as hardware, patching, backups, making sure the backups are correct, making sure they can be restored, managing failovers, fighting fires, scaling the databases, moving the databases, installing software, all of those things. They're activities that everybody that's running their own databases have to do, but they're not necessarily bringing value to the organization. They don't set you apart from your competition, right, from an organizational point of view. So if we can take on those activities, then you as a customer are able to focus on what are really the more important and more valuable activities as far as interacting and managing a database, such as design of schemas, query construction, optimization, and things like that. So when we're talking about moving to manage relational databases, we're really talking about a conscious choice to reduce some of that database administrative burden. You get, in some cases, are able to take advantage of better performance or better availability or better scalability or better security, depending on where you're coming from. There's a lot of other advantages that come along when you're adopting these managed databases. And the great thing about the choice of database engines that we offer, that, they can be drop-in replacements, right? You don't need to re-architect existing applications. You can simply point your applications to a managed database instead. And in our particular case today, we're talking about MySQL, right? So, you would be able to migrate MySQL workloads, in RDS to largely the same versions of MySQL that you would otherwise run yourself. And since I mentioned versions, in Amazon RDS for MySQL, we offer the MySQL Community Edition engine. We just wrap an automation and management layer around it that makes it easier for you to configure and manage. But we support all the major versions of MySQL, all the way from 5.5 all the way to 8.0. And, we allow you to create high availability solutions and deploy highly available databases across 2 availability zones within a region, protecting you not only from individual hardware failures, but also, data center-wide failures. You can also create read replicas for these RDS databases. These read replicas can be in the same region, or they can even be in entirely different regions, and we use binary logging for that, just like you would normally creating read replicas yourself. We provide built-in backup and restore capabilities, and a choice of different instance classes and storage performance levels that are designed for different types of workloads, right? If your workloads are more compute heavy, you can certainly take advantage of some of our more compute heavy instance classes. If your workloads need more memory, we also have memory optimized instances, and we also have, burstable compute instances that can address the needs of some of the smaller databases that perhaps have more variability in nature.
Okay, the value proposition of Amazon RDS sounds really interesting. How does the role of a DBA change when we interact with managed databases, Vlad?
mentioned before, it's all about eliminating that undifferentiated heavy lifting. What we've seen from the customers that we work with and that have migrated to RDS MySQL is that in the past, they used to spend a lot of their resources and time dealing with the platform, right? Provisioning servers, patching servers, dealing with backups, dealing with troubleshooting, firefighting type activities, and that left very little available resources or available time to deal with the higher level considerations around the applications. How does the database interact with applications? How the queries optimal? Are databases monitored in the most optimal way? Are the access controls set up correctly? So all of those aspects are took essentially a secondary. They were deprioritized. They fell into a secondary bucket. And what we see when these customers move to AWS to adopting RDS is that their administrator now spent a lot less time dealing with the platform, right, with activities around the platform, but have more time to work and optimize data models, or understand and tune the configuration of the database to get the best possible performance, or optimizing their monitoring strategies and so on. So all of these capabilities interplay, but we see basically a very big shift into the type of work that DBAs or other types of developers or administrators that are managing these platforms do. Now, let me give you some examples, right? So I talked about tuning and configuration in a database, right? Whether you're migrating or starting a new workload. When we're looking at MySQL Community Edition, configuration and tuning is largely file-based. You have that myCNF file. You might have the ability to set some configuration parameters dynamically, set global variable to a certain value. But fundamentally, it lacks built-in centralized auditing of the parameters. Over time, the knowledge of why a certain parameter got changed by whom and for what reason gets lost in time. And when you're reevaluating the databases, you no longer really have that background information. There's also questionable default values that MySQL honestly inherits from one version to another that you have to contend with. And you have your own kind of legacy configurations that get inherited, right? You might have started your database, I don't know, version 5.5, you're now running on 5.7, but over the years, the configuration that were ideal for 5.5, they just get inherited over to 5 as you're upgrading to major versions, but nobody really reevaluates and saying, hey, does this still make sense, right? So all of that additional work, it's not very efficient. In RDS, we provide what we call parameter groups. These are essentially containers for parameters that provide centralized management. You can take a parameter group and apply it to multiple databases. You can reuse it that way. They're specific to different versions. You have auditability. Anytime a change happens in the parameters, it gets recorded in our cloud trail, right? So you can track down who changed what over time. We have some parameters that we tune for you, mostly values that have to do with kind of the size of your instance, the amount of memory, and so on, right? So you'll see some values that have formulas like that. You have the ability to create your custom resources, but still, some parameters we still inherit the MySQL defaults for legacy purposes. So here's how you would manage parameter groups, right? Every instance has to have a parameter group, whether that's the default one or a custom parameter group that you create. Parameters in those groups can be dynamic, right? They can take effect immediately, which is a non-destructive change. Or, they can be static, which would require a manual reboot from your part. We don't do the reboot for you. You have to actively reboot the database to make that parameter change. Some parameters are modifiable, and yet some of them are not, right? We have reserved and we're holding some parameters where we don't allow you to change. because they wouldn't impact our ability to deliver the service, but we still surface them to you so that you have access to them. So, you have visibility into the values. Some parameters are blank, which means that the values are generally inherited from MySQL. Some parameters are formulas. We size those automatically, such as the size of the buffer pool based on the amount of memory. Some parameters have explicit values. If we deem that a better value, putting one explicitly is actually worth it. And the other example that I wanted to showcase, the other aspect as far as managing and operating these databases, you have to deal with versions, right? When you go to RDS MySQL, it's the same MySQL code base that the Community Edition uses, right? We just have the management layer around it. So what you'll find that we broadly track with the MySQL Community Edition for version availability. MySQL hasn't been really good at kind of having a regular cadence for the major versions, but we're trying to kind of align and track those same versions. You usually find us releasing the newer versions pretty closely after the community releases them. Not all features may be supported in all major versions. That's certainly part of MySQL, as well as part of our platform as we're adopting these newer versions. Some features might take us longer to test and validate and make sure that they're safe to use with our platform. And we support in-place upgrading. So if you have a version 5.7, you can upgrade in place to 8.0. We provide all of the tooling and all of the automation to execute that update. You just need to tell us and trigger that update using an API call or through the console. Now, there's of course best practices in managing that. These are not anything different than in the MySQL world. You always want to upgrade your read replicas first. And you should leverage your read replicas to promote them and cut over with minimum downtime, right, to minimize the amount of downtime during the upgrade window. So these are best practices. I'm sure you're familiar in the MySQL world as well. But the emphasis for major version upgrades is we're trying to make them as safe as possible, right? And we're trying to follow MySQL established best practices. So if you do a major version upgrade, we will run the MySQL upgrade binary, part of that process. This might make changes to your system schemas, might convert some data. It depends on the version and what, compatibility differences there are between them. But we will take a snapshot of the database before we start the upgrade process, and we will take one at the end. So you can always have a safe spot to go back to. That is, of course, assuming you have backups enabled. Typically, upgrades tend to take about 10 minutes to complete, and the database is not available during that time. There are some exceptions, right? So upgrades to 5.7 may take longer because there's temporal data type conversions that need to be performed. If you have temporal data types, defined with the formats that were in 5.5 or even older versions of MySQL. If not, then that's not a problem. Also, upgrades to 8.0 run a series of pre-checks due to changes that are breaking compatibility. Those are all, part of that upgrade process, part of the best practices of the community. So you really won't be able to upgrade to 8.0 unless all those checks are cleared. Now, and as with regular MySQL, once you upgrade, you can't roll back, right? That's why we do those snapshots for you so you have a safe space to come back. And we also provide a feature for automatic minor version upgrades. These minor version upgrades can be either manual or automated, right? And we perform these in place, and that's relatively simple. We just stop the database engine, we replace the binaries, and start it again. Again, it can take a few minutes, right, to complete that process. We enable automatic minor version upgrades by default, but you can, of course, turn that off if you want control of when and how those updates are performed. And automated upgrades are scheduled during the maintenance window. So the maintenance window is a period of time, about 30 minutes, minimum 30 minutes, that you define and you control when, over a span of a week, when that window happens. You always have to have it. And if there's maintenance work that needs to be done, or you schedule maintenance work, such as changes of parameters or, reboots or all sorts of things like that, those can be executed during that maintenance window. Typically, you want to set it to a time when you would have the least amount of impact if your database would be rebooted during that time window. It doesn't mean that your database is going to be rebooted. It just means that when there's a need to do that, that's when you want to. That's the time window where it's relatively safe to do so. And we perform automated upgrades for versions that are lower than what we call our preferred version. So while we do generally make all of the newest versions available relatively quickly as they are released by the community, we also have what we call a preferred version that is a little bit more of a conservative, safe option, right? Where we know that there's not that many issues related to debugs and so on. And then we typically only kind of automatically upgrade you up to that preferred version. That might not necessarily be the newest version.
Okay, now that we understand how some of our roles might change when we manage and operate these managed MySQL databases, right? How do we perform migrations from on-prem? What kind of options do we have?
That's a great question. First, before we kind of approach the topic of migrations, the first thing you want to do is plan and understand your requirements, right? Migrations, in my experience, there's no two that are the same, right? So there's always considerations as far as what's particular about your workload. And it's important to understand those before you start. I personally would ask customers, right, that are undergoing migrations, the following set of questions, at least at minimum, right? What sort of MySQL version are you running on? And do you want to migrate to the same version or to the next version, right? What is the size of your database? How big is it? That affects the amount of time and amount of work to execute the migration. Or do you want to migrate the full data set or only parts of it, right? This is an important question. We have a lot of customers that are software as a service applications where they might have single tenant schemas. They might want to reduce the risk by only migrating certain customers, one or multiple customers at a time, and do it gradually. What are the minimum downtime requirements? Everybody wants to have a no downtime and no disruption migration, but that's often not feasible, right? So what are the realistic minimum amounts of time that you can allow at least the rights to stop, right? Do you use replicas today? Meaning, do you have binary logs enabled on your databases? If so, what configurations do they have? How do you back up your data today? Are you using, what mechanisms do you use to back up the data? Can those be used, and you'll see in a little bit, can those be used as a starting point for migration? Do you have specific security requirements or encryption requirements for data protection, right? Do you need to have end-to-end encrypted replication between your existing on-premises self-managed database and RDS MySQL? Or do you need, or is it okay if you just have a VPN connection between those two private networks, right? So there are a lot of considerations that are important to just, understand at the beginning, because they will influence which options are better suited for your needs. And speaking of options, there's generally three major options that we have that customers use to migrate to RDS MySQL. It's often tempting to say, I want to pick just the one that works for me, right? Or tell me which one is the best option. But really what we try to encourage customers to do is narrow it down to a couple of feasible options based on your limitations and then try them all. Because there are differences in how they work. There's differences, of course, your workload is different than many of the other workloads out there. So your outcomes might actually be different than other customers' experiences. But generally, there's 3 of them that we recommend to customers. The first one is migration using a physical restore from backups. So if you're using today in your data center Percona XtraBackup files, right, and that tool for backup purposes, you can simply upload those backup files to Amazon S3, and we can create a database instance based on those backup files. Optionally, you can use binary log replication to catch up with changes and execute a minimal downtime migration. The second option is this uses native or ecosystem tools, right, to export the data in a logical format, CSV files, actual SQL statements, and then import and apply those on the other side. And this can also be paired with binary log replication to execute a minimal downtime migration. And the third option is using our AWS database migration service. Using DMS, you can perform a full data load as well as capture the changes and execute the migration that way. It's also a logical migration. It's just a managed service that actually is performing all of the steps in that migration. So let's look a little bit more in detail in these options. I'm going to start with the physical migration options. So if you were to migrate using XtraBackup files, this is typically the preferred option due to the use of native tools and that it's typically faster than any of your other logical export and import options, right? If you're already using Percona XtraBackup today, it's also very simple to use. You just take your backups, ship them to S3, and create a database instance out of those. You can upload those backup files to S3. S3 provides, optimized parallelized loading capabilities, so you can really take advantage of the many kind of aspects to accelerate the actual data movement. Now, this option only works with RDS MySQL 5.6 and 5.7, right? And I mentioned before, you can use native binary log replication to capture the changes and minimize cutover and downtime. There are some limitations that do apply. This is a physical migration, right? You're not actually using the database engine to pipe all of your data rows through it. So typically, it only really works well if your on-premise configurations are relatively close to what the configurations are in RDS, right? So for example, you can't use encrypted backup files. You can store backup files on encrypted storage and transmit them over encrypted connections to Amazon S3, where you can also store them in encrypted format, but the file itself cannot be encrypted. It doesn't migrate your stored procedures, functions, and time zone settings. Those have to be imported separately. And it really only works if you use the default file paths and file names for InnoDB. Typically, it expects that there's an IBD data 1 file there in the default directory, and if there isn't, that's not going to work. And there's very specific versions that this option also works with. Might depend also on the regions, but typically it's 5.641 is the newest version that you can migrate to, 5.722 is the newest one, 7. So these are what we call those preferred versions. You can only really migrate to those. So let me show you a demo of how migrating using Percona XtraBackup works. Now, just to make the steps for the demo and setting up the environment are in your lab guide. I've already pre-created some of these databases just to save on time. And I'm going to toggle over to my AWS Management Console. And the first thing I'm going to show you is that I do have an EC2 based MySQL database. This is a self-managed database. I'm going to log into that database real quick. I have some data sets loaded in there. All right. So I have a couple of databases here. They're small databases. We wanted to keep the size small just to kind of illustrate the process, not necessarily performance implications of large data sets. So we have a database, has a couple of schemas in it. And the first thing we want to do is create an XtraBackup file. And the command is really simple, right? It's also in our documentation. I'm going to just copy it really quickly out of my Scratch pad here. It's XtraBackup backup, using what username to use, where to deploy the backup. So I'm actually using XP Stream, and I'm splitting the backup into 2 GB files. This won't be necessary for such a small database, but you know, if you have larger databases, you do want to chunk those files up. So the system is going to essentially back up all of my InnoDB table spaces, as well as capture bin log position, as well as transaction and log information. So the backup is completed. I have the files on disk. The next thing I'm going to do is really quickly change ownership of that folder, because I did use a sudo command. So next thing, I am going to upload these files to Amazon S3. And this is also a very simple command. I'm storing them in a S3 in a folder with the timestamp of today and 1:30 Pacific time. And the data is being loaded and uploaded to Amazon S3. All right, so my files are in Amazon S3 now. One thing I didn't show you earlier, while we're doing this, I had set up a script for myself that's actually sending data and inserting rows into the database while we're doing these operations. So the database isn't actually just sitting still, right? It's actually changing the data, and that'll help us later, because I'm going to also show you how to set up binary log replication to catch up with changes. Now, we have our database loaded into S3. I can go to the RDS management console, and I can simply click this button here that says Restore from S3. I'm going to choose the bucket where I stored my backup files, and I'm going to also provide that prefix, that folder name that I stored those backup files before. And then I'm going to choose MySQL as the target engine, and this is a 5.7 version of a backup file, and you can see the only option available here is 5.7.22, which is our preferred version. I am going to create a new role for this operation. Now the IAM role is used to allow RDS permission to access the S3 bucket. Sorry. So I'm going to just go ahead and create a new one. And I'm going to name my database instance. So this process and these settings here are very similar to what you would choose when you create a new database from scratch. I'm going to create a master database user and give it a password. Remember is when you do a restore from backup, you want to use a different master username than what you use on than any of the user accounts that you actually have set up on your source database that we took that backup from. If you try to, you reuse the same username, it might, the restore process might fail. This is important because, typically we want to kind of have consistent naming as far as administrator account across our databases. So this is one place you probably want a different username. I'm okay with the default configurations for memory and instance size. You of course are, you can change these and pick different instance types out of different categories with different amounts of memory and CPU capacity, networking throughput. And I'm going to also choose general purpose SSD and put 400 gigabytes of storage. I don't need nearly enough, but that setting allows me essentially to have a little bit over 1,000 IOPS as a baseline for my storage capacity. And I'm going to choose the network where I want to deploy this backup. And the firewall configuration, the VPC security group. I'm going to pick one that I already have. So this allows us to access the database. Now, the question came in the meantime, this version here. You can restore with Percona XtraBackup to a higher version, but it cannot be higher than this, right? And it cannot be, what you can't do is if you have 5.7.30 that you're running in the data center, you can't restore that into 5.7.22. But if you have an older version than 5.7.22, you can restore it to up to this version. So this is the highest version you can restore to. And you can only restore older version or the same version. The other configurations are, we can leave those default for our purposes of our demo. So I'm just going to go ahead and create the database. It'll take a few moments. The system has to validate that all of the information I provided is correct, and then it will go ahead and start creating the database. I wanted to show in the meantime, actually the second time we tried that to create that restored instance, it's running right now, it's creating. I do have one that's already, I've created about an hour ago. We don't want to wait until, it'll take about 15 minutes to create that database. So what I'm going to show you next is how to connect and set up binlog replication. So we have the database running. I'm going to use a different one. One important aspect that I wanted to show is when you go to the database, there's two pieces of information that we need. One is the endpoint, so we know what database to connect to. And the other piece of information is here under logs and events. So when we restore a database from backups, Amazon RDS will tell us what the binary log position for that restored instance was. So we can use this information to just start replaying bin logs from that source database that's outside of, that's not managed by AWS. So you don't actually have to use the Percona XtraBackup prepare phase or anything else. We do that for you, and then we produce that information when we restore the database. So I'm going to go ahead and quickly connect to the database. All right. And the other thing I wanted to show, we also already have the data. You probably want to do some validation that is more comprehensive than this one, right? Of course, when you're doing a migration. But you can see we have the schemas with the same data that roughly that's on the master. And also wanted to show you that we are migrating some of your users. So from the data, the source database had these two user accounts, master user and replication user. Master user actually on the source was a super user, part of the migration process, and we actually turned that off. And we're not migrating your root account. So if you have the root account on your source database, like I did, you don't have this. Now this might present an interesting situation because some customers actually have views or store procedures or other code or other objects that are defined, that have a definer of root. Those objects will be imported, but they're not going to be usable here because that root user doesn't exist. So you will actually need to reconstruct some of those objects if they have those types of policies. Again, this is a physical migration, so you're getting the same data that you had before. For example, if some of those objects are migrated. Store procedures aren't, but views are. So let me go ahead and set up replication. So that is a command, and I'm going to go ahead and use that file position that I have here in the logs. So binlog 001. And we're just copying these values to my scratchpad. And now the way you configure binlog replication from a slave perspective in MySQL here is using some store procedures that we provide out of the service. So this call MySQL RDS set external master with the IP address, the user account, and the binlog position. And then we have a corresponding store procedures that invokes and that starts the replication. And now I can just monitor the replication using the regular MySQL commands. The system is going to actually start processing data. You can see here some of the data. You can see seconds behind master, about 6,000. If we just started and I have about an hour's worth of changes, right, that I'm replicating, these values are going to slowly reduce. You can see the positions actually change as we are processing this data. And eventually it'll catch up, right? The seconds behind master starts dropping. We were over 6,000, now it's 5,000, and so on. It'll take a few minutes. I'm not going to wait for the data to catch up, but what I wanted to say is that typically when you see the seconds behind master 0 in messages such as this, the master has caught on with or the slave has caught on with the master and some of these other messages, at that point you probably want to execute the actual cutover, right? You would stop writes on your old database, you would set it into read-only mode, you would repoint your applications to Amazon RDS and then enable writes over here. So this was my demo for using Percona XtraBackup and just creating a database directly out of Percona XtraBackup. Let's go back. Let's go back to our presentation and talk a little bit more about the other options. So the second option is migrating using logical export and import. This is really a very reliable option if your data sets are small, or you can import them or export them for that matter in a parallelized way, right? The simplest tool that you have available is MySQL dump. It's really only suitable for very small data sets up to a few tens of gigabytes, unless you somehow developed your own orchestration around parallelizing this process, right, and using multiple MySQL dump processes in parallel. Another tool is MyDumper MyLoader. It's suitable for parallelized export and import operations. It does that natively, so it's much more suitable for very large data sets. But at the end of the day, it's still a logical export and import process, which means the import side is going to go through the database engine interpreter and execute essentially SQL commands to load your data. So the amount of time it'll take to do that initial load depends on the dataset size, depends on the degree of parallelization, instance type, storage characteristics, and things like that. You can, of course, use native bin logs for capturing changes and minimizing cutover downtime. All right, so like I was saying, there might be some complexities around getting a transactionally consistent export, right? Especially if you need an accurate bin log position. Some customers use replicas to do the initial export and import, and then coordinate a transactionally consistent bin log position. Other customers use other mechanisms like locking the tables. So there's a couple of ways, but they're not entirely seamless, right? It can potentially be disruptive if you're migrating a production workload. But the key takeaways here is parallelization, right? And using big instances for the data ingest, right? With a lot more capacity than you necessarily would need for the normal operations. And migrating using AWS DMS is not necessarily any different than logical migration in many ways, right? DMS itself is a multi-purpose service that is easy to set up and operate. The advantage that you will have there is that you can use a point-and-click interface or a couple of different relatively simple API calls to invoke and provision the right resources and perform that migration. We recommend you use a full DMS load and CDC task that will give you the best fidelity and minimizes downtime during the cutover for a migration. You can, of course, just do a full load, or you can only do a CDC task, but mixing and matching native tools with DMS can be a lot more work than just simply using that tool. The same recommendations as with logical migration apply here. Configure the level of parallelism. You want to balance the migration speed with the impact on the source. You can, with DMS, do a partial or selective data loading, right? With native bin logs, we don't support filtering, which means that it's always going to be everything. That all of the bin logs events that the master generates is what you are going to be replicating. With DMS, you can do selective, right? Maybe only certain schemas or certain other patterns you might want to migrate. And again, use larger instances on the target to accelerate that initial database load. One recommendation that I always have for customers, always enable all of the full logging capabilities possible in DMS. Migrations can be complex at times. So, it's always good to see what was being migrated and how, and if there's any errors or issues, how to fix them, what caused them. For the CDC part, it needs a particular bin log configuration. The bin log format has to be row, and the bin log row image has to be full. There are a couple of other limitations that might apply, especially for the types of DDL operations that DMS can't replicate over. Check the documentation, that the list of limitation is shrinking constantly, so want to make sure that you're using accurate information for that. But for example, today you wouldn't be drop table operations aren't replicated. So here's a demo of using DMS for logical migration. I'm going to go ahead and go back to my screen, and I'm going to go ahead and do a couple of things. So first, because we're doing a logical migration, right, the first thing we want to do is create a database. And this is a similar process to just creating any database. You go here to create database. We'll use the standard process. We're going to choose MySQL. And this time I can use the newest version of 5.7.
Glad I can't see full screen. I see you pretty.
Let me try to. I'm going to go ahead and recycle my screen sharing again.
Yeah, now it looks good.
So right now what I was showing is the create database screen in RDS. We're going to create a database. Just, most of the configurations we can take honestly from the defaults. I'm going to pick MySQL, pick 5.730. I can pick any newer version. I'm going to use dev test template because I don't want high availability during that migration. That's just initial overhead on the database. I'll give the database a name. And the same configuration considerations, a username, I picked a default instance type. I'm going to use the same configurations I had before, 400 gigabytes of general purpose storage. You can enable auto scaling. That way, if your datasets grow over time, the storage will be automatically increased. Connectivity, put it in the same network configuration as with in my desired network configuration, as well as the security group. And everything else I can accept as default, at least for the purposes of this demo. I'm going to click Create Database. Now, I already have a database that I've pre-created because it will take, again, about 10-15 minutes to fully provision this database. And it's this one, DNS Target Database. All right, so I'm just going to go ahead and use my SQL dump to download the schema. Now, I mentioned the definer policies earlier, right? So I can show you that I have, kind of how that file looks like. It's a simple command file, right, with SQL statements. And I mentioned those definer policies. I actually have views in one of my databases that were created with a root definer. And this is obviously a statement that will fail if I run those on the RDS instance. So I'm going to use a simple this Linux sed command to just replace the definer with the one that I'm using, the account that I'm using to import the data. So cleaning up. So you do need to run some of these types of cleanup operations on the schema. And next, I'm going to simply import that schema into the database. Oops. All right, so now I have those schemas on the database. I can actually connect and verify that. And there we go, we have those schemas here loaded. So once we're done with this step, I'm going to go ahead and switch over back to my console, AWS console, and go to the database migration service. And hopefully you can see the screen, but if you don't, BJ, please let me know. Apologize for all the technical difficulties. I already have a replication instance for DMS running. It'll take, again, it takes about 10 minutes to provision that, but DMS uses this replication instance to actually operate and execute those tasks. This is what runs those migration tasks on your behalf. So this instance will connect to your source and will connect to your target, and then export the data and import it into the target. What we need to, however, set up are two endpoints. So one of them is going to be my source database endpoint. This is going to be, I can give it a name. This is my source database that's outside of RDS. This is my server IP address. This is my SQL database. And the server name, I'm putting the IP address of the server, of my database server. The port is the standard 3306 port. username is master user on that database, and I'm providing the password. All right. There's no additional configurations we need to do for this, for the source, but I am going to test to make sure that the connection is valid, right? I'll pick the VPC and the replication instance and run a test. We want to make sure that the endpoint is usable and can connect to the source database. And that takes a few seconds. So DMS in general is a tool that allows you to replicate and move data from one database to another, but it can also do that between different engines, such as from, let's say, MySQL to SQL Server or the other way around. And that's why you can create these endpoints and mix them in replication tasks. All right, I have one of my endpoints running. The other one is my target endpoint. This is a bit easier. Since it's an RDS instance, I can just check this box, pick my RDS instance out of the list. It'll automatically pre-populate some of this information. And we do actually have to provide a couple of extra settings here. And I'll explain both of them. The first setting in this list, parallel load threads equal 4, I'm just telling DMS to parallelize the data load and use concurrent multiple threads to actually insert data into my target database. And the second one is turning off the foreign key constraints in MySQL. Because the data will be loaded by DMS and may not load it in your foreign key order, especially if you're doing parallel loads. So it's recommended to turn foreign key checks off in MySQL during that initial data load. So this is the statement that turns that off. It will automatically re-enable it when it starts replicating changes. And I'm going to go ahead and test the endpoint again. Make sure this one works as well. I'm going to go ahead and give the task a name. I'm going to pick that replication instance. That's where we want to run that task on, the source endpoint and the target endpoint. Oops. And I'm going to instruct it to migrate existing data and replicate ongoing changes. So this is a full load plus EDC option that I talked about earlier. We'll start the task automatically when it gets created, and I have a couple of settings here that I want to emphasize. Table preparation mode, we want to do nothing. Like I mentioned before, the other two options work in certain circumstances, but you can't drop the tables on the target because DMS is likely not going to create them with the same level of fidelity. It doesn't, for example, create secondary indexes, or it might translate some columns to different data types because of its internal data mapping policies. And the third option, truncate, doesn't really work if your tables have foreign key dependencies. So the recommended way to do it is just do nothing and manually drop your schemas or your tables as needed before you're attempting these migrations. Everything else I'm going to leave as default. If you have large blobs or character blobs, right, in your database, you probably want to adjust these settings. I will enable validation, and like I mentioned, I'm going to enable logging. And I'm going to pick the info log level. You can go all the way down to detailed debugging. You always want to have as much as logging as reasonable, although some of the debug levels can be quite chatty, so it'll be more difficult to kind of see the information you need. I will tell DMS which tables and what data to replicate. I'm going to use the guided UI, add a new selection rule, enter the schema name, employees, and I'm going to add another one for another schema that I have here that's That's actually the one that is receiving changes. Under advanced settings, we want to enable the control tables. These are tables that give you information and statistics as far as exceptions, status, history of jobs. I prefer to enable them all. They'll be saved on the target database. And that's it. I'm going to go ahead and create a task. It'll take a brief amount of time to create it, and then the task will start. Once it's started, you will be able to see the amount of data moving and being replicated or imported and exported from your source. It first will import and export the data, and then it will replicate the changes. One interesting thing, however, about DMS is that it actually starts capturing bin logs right before it actually starts reading your initial data set. All right, so this task has been created. It's now starting. And this approach of capturing bin logs before we even start downloading the data means that it's less disruptive in terms of getting an accurate, transactionally consistent result, right? We don't have to log tables. We simply capture the bin logs, and then there's a step, part of the migration process, where we are applying what we call cached changes, and we're reconciling any conflicts in the data to give you a fully transactionally consistent data set before we start a standard change replication. So it's running now. I'm going to go to this table statistics tab, and you'll see essentially all the tables that I am replicating out of these schemas. How many rows it's discovered, how many rows it found. And you can refresh this, and the values will change. As it loads data, it will also validate those records. You'll see which ones are validated, completed, which ones are still loading data. This one, all of the rows have been loaded. Now it's pending the validation for those rows. So this process will continue until all of the data is validated, all of the rows are loaded, and I believe you'll see already here some of these changes that we captured already as we're loading some of this data. So this is the CDC part. We have about 1,300 rows that are being inserted already, part of the CDC process, and that this number would obviously keep changing. So this is how DMS works. It's quite easy to use. There are some, manual steps even here that you need to complete to get the best results. I'm going to go ahead and quickly switch back to our presentation. Let's talk a little bit about best practices, right? And we mentioned some of these best practices along the way. And I like to kind of separate them between best practices for initial data load and export. When you do native logical replication, or DMS for that matter, make sure you parallelize as much as possible, or use multiple threads. When you do your own native logical exports, make sure the data is ordered by primary keys. That being said, make sure that all your tables have primary keys. Right? Binary log replication, especially in row mode with tables without primary keys, is really problematic. Skip the system tables, right? You can't change those on the target in RDS anyway, so they'll just cause errors. Skip stored procedures, functions, and triggers and events in your initial data load, and then just load them later on when you're ready to do the cutover. Disable foreign keys for the initial import, and try to capture a transactionally consistent bin log position if you want to do minimal downtime migration. With DMS, the recommendations are similar, again, around parallelization. Use a right-sized replication instance. If you have lots of data or lots of change records, you need to have enough space on the replication instance to actually capture all of those bin logs all the way from the beginning. And you also need to have a big enough instance to handle the parallelism that you need in terms of both reading the data and writing it to the to the target database. There's different recommendations I mentioned around large objects. Pre-create your schemas manually, right? This is going to be by far your easiest path that avoids most of the kind of the differences and idiosyncrasies in how DMS maps the data type from the source into its internal format, and then from the internal format into the target, which might not really, so it might not necessarily replicate quite the same fidelity of data types when it creates tables on your behalf. That's not a problem for the data, but for the schema itself, right, creating the actual table, you want to do that manually. Disable foreign keys and disable triggers and events on the target until you're ready to cut over. For binary logs, make sure the tables have primary keys. I can't emphasize that enough, right? Especially as you're using row-based replication. This can become problematic. On the target, MySQL does provide stored procedures like you've seen to configure the master, stop it, start it, pause it. So you want to be able to make sure that you use tooling that actually supports those stored procedures or do it manually. Some systems and some orchestrator systems don't, so you might not be able to use them. Make sure you have sufficiently allocated storage to handle that change rate if you do use DMS. And be aware that GTID bin logs are not yet supported in RDS MySQL 8.0. They work in 5.7. A couple of other best practices, generally for the RDS platform. Don't use multi-AZ for the initial load, right? It's just additional load, additional work that the server has to do to manage that replication. And you can always turn on multi-AZ right before you want to do a cutover, maybe after you finish the initial load and you're in that bin log replication mode where the load is comparatively less. Also set up the backup retention period in RDS to 0. That will turn off bin logs on your target, on your RDS instance, at least for the duration of the initial data load. And consider using a bigger instance size that can handle running multiple parallel threads loading that data in. I prepared a kind of a little summary slide here with the different options and kind of the suitability. You can do minimal downtime migration pretty much with any of these options if configured correctly, but you'll see that there's differences in essentially how fast your initial data load can be, right? Backups with XtraBackup is typically the fastest option. Native MySQL dump, it's slow, and unless you parallelize it, it's going to be even slower. My dumper, my loader, you can get pretty decent native parallelization. And DMS, you also have very good controls to figure out how much data can be loaded in parallel. Be advised, though, that with DMS, by default, we only parallelize loading different or reading different tables concurrently with parallel threads. There is a setting where you can define ranges, so DMS can read from the same table using multiple parallel threads, but you have to do that. If you use partition tables, it will do that automatically, but if you don't, and you have workloads where you have many very small tables and one or two very large tables, defining those ranges and breaking down that big table and downloading it in parallel would make a huge difference. And yeah, thank you very much for attending our session today. We wish you a great rest of the day.
Thank you.